Hello friends, welcome to Chella's Kachunner. In this video, we'll see about Pareto Chart in detail. So Pareto Chart is one of the 7QC tools, and in this video we'll understand about it and we'll learn to draw Pareto Chart in the Excel sheet. So what is Pareto Chart? So it was invented by Wilfredo Pareto. He's an Italian economist. So he invented that 80% of money in the world was lying with 20% of people in the world. So this was well appreciated among the economist group. So this concept was introduced in the quality field by Joseph Juran, and it defines 80% of problems occurred by only 20% of causes. So majority of problems are contributed by very limited causes. That means vital few, trivial many. So it helps to focus on only 20% of area to get a 80% of result. So less area focus, maximum result. That is what principle of Pareto chart. So it used to identify areas to focus on the first in the process improvement. And it's a combination of bar and line chart. Bar chart denotes frequency and line chart represent percentage contribution. So it can be applied for only ordinal data. So what is ordinal data? Let us just have a small info here. So in statistics we have four types of data under the category of two. One is categorical data, and second one is numerical data. So under the categorical data there are two types. One is nominal. Nominal is name based. It's like men, women, students, workers, that all type of data will come under nominal data. So ordinal data, it is there is no number, it's a feedback or attribute data, but it can be ordered in the sequence. It's like low, high, medium. So in the survey you might have seen like strongly disagree, agree, strongly agree. These all will be coming under ordinal data. The second category is numerical data, that is a quantitative data. That discrete is the first type, that is numbers, that's purely counts, number of candidates, it's a count. And second one is continuous data, it's a numerical data, it's any measurements taken through instruments, all coming under continuous data. That is like examples, distance run, weight of the object, this will be a continuous data. So for drawing Pareto chart, the data should be in ordinal form. Then it will be converted into frequency for each and every category. So now let us understand how to draw a Pareto chart in Excel sheet. So I have taken a service sector example. So it's like a small example and imagination. So in India there are so many applications are pending for providing Aadhaar card. So there is a government scheme is going to be released. For that, government has to complete all the applications of Aadhaar card. So that is small panel has formed. So they were confused and they want to take a decision how fast we can close these all applications. So for that they collected the data of 50 cities. So you can see over here 50 cities. 50 cities total pending of application is, it is like 2 crore 19 lakhs 54,774 applications are pending. So with this data we'll proceed for making a Pareto chart. So what we want to do, collect the data. So application received city wise, that is the base data for the Pareto chart drawing. So we have to arrange the data in the descending order, highest to lowest, it has been done, highest in the top, lowest in the bottom. So next we want to just calculate percentage contribution city wise. So earlier slide we have seen ordinal data. This is the ordinal data, city-wise data, categorical data, and we made it in the order. So what we want to do is we want to calculate cumulative first. Cumulative means it's like first if you see the Mumbai, the total amount is this much, and next Delhi city, it is a cumulative of previous plus current city's total application pending. The same way, it's a cumulative will be calculated each and every city. I mean, the total summation till previous one and current city's total pending, it's both added together. It shows the cumulative till this point. And further, the cumulative will be divided by total in each and every line. So that will show the contribution, cumulative contribution basically it is. It's a cumulative contribution of pending. Like Mumbai is having 11% contribution and Mumbai and Delhi put together is having 21% contribution. That is what cumulative contribution of pending in total. So after calculating this, we have to go for. Now let us draw it in Excel sheet. So what we need to do, we need to select a graph. There we need to take only 3 columns in that Excel sheet. The data we have seen in the previous slide. One first column, that's cities and application pending and percentage of contribution. So we don't want to take the cumulative column in for the graph preparation. So after that we have to select the graph, bar graph as an option. Then the graph will be drawn. So in that graph we need to make small changes to get this shape. First one is, so we need to go to the chart change type. There for the Y1, that is a cumulative one. First we need to convert that in as a line chart. Then the values you need to transfer to secondary axis. There will be an option there you have to make the box check in. So that will make the Excel sheet properties that will be made as a secondary axis. Then we need to ensure that maximum value should be the total of the application pending in the y-axis. The y1 axis it has to be 100%. Then only these both graphs will be getting merged properly. There will not be any mismatch or it will be properly touched and show the full image of Pareto. So after drawing this graph, what we are able to understand out of this graph. So first, there are 50 cities which are having, so many applications pending over the cities. So after plotting this one, so we are able to understand only 11 cities are contributing to the 75% of pending application. So only by focusing on 11 cities, the government can take and close 75% of pending. So instead of focusing on all cities and making so many special task force in all cities, only making 7 small task force into these top contributing cities, they are able to close this 75% of pending in a very faster manner. This is what Pareto charts benefits. Like we saw in the previous slide, so the advantages are it helps to prioritize and focusing on high contributions, and benefits can be easily interpreted. Like we saw that like Mumbai was having 11% contribution. So by only closing Mumbai, the benefits of closing 11% of pending application will be benefited. So same way benefits can be easily interpreted, and very low skill level is required. So anybody can draw after small training. So it's very easy to present and interpret. This data can be present to anyone. They can easily interpret the data, and it's used for macro level analysis. This, if you see, it helps only just for a macro level analysis. So it does not have any root cause analysis tool. It cannot be used. Like we don't know why there is such a huge pending. That question we don't have answer. So it cannot be used for a root cause analysis of any single problem. And it is not defining the severity of problem. If you are making you are only making prioritization based on the frequency. Maybe the first one may not be severe defect if you are drawing Pareto chart for the engineering application or engineering defect reduction. So you may be you will be drawing only based on the frequencies. So first one may be top in frequency, but the defect severity may not be higher. So it does not define the severity of the problem. Second one is it's only purely reactive tool. It only helps to solve the problems. It is not a proactive tool. Friends, please like and share this video. Thanks for watching. Thank you.